Hi, so in this example, we're going to demonstrate a goodness of fit test to see whether a distribution is a good fit. So it says an Acme toy company prints baseball card. The company claims that 30% of the cards are rookies, 60% are veterans, and 10% are all-stars. Suppose a random sample has the following cards. Test Acme's claim that the distribution is a good fit with the prints of the baseball cards at an alpha of 0.05 level of significance. So they give us the categories of rookies, veterans, all-stars, and they tell us that when they observed their sample, they got 35 rookies, 105 veterans, and 10 all-stars. However, their company says that if you, whatever packs you get, 30% of them will be rookies, 60% of that pack will be veterans, and 10% would be all-stars. So these are the observed. Let's go ahead and calculate the expected frequencies. So the first thing we need to note is that all the expected frequencies should be more than 5 and 20%, or all of them should be greater than 1 and no more than 20% should be less than 5. So let's go to the calculator and let's take the sum of all the observed frequencies. So 10 plus 105 plus 35. So our sample is 150 baseball cards, and of this 150, we expected that 30% of them should be rookies, 60% of the 150 cards should be veterans, and 10% are all-stars. So if I multiply the rookies percentage, 30%, by my sample, I should have expected to get 45 of these cards to be rookies. For veterans, I expected 60% of the 150 cards to be veterans. So I should have expected 90 out of the 150 to be veterans. And the last one is I expect 10% of the 150 to be all-stars. So I expected only 15 of this 150 to be all-stars. Okay, and I can see that all of the expected frequencies are larger than 5 and definitely greater than 1. So then we can go ahead and start conducting our test. Now we do know that the null hypothesis, we always assume status quo, that this distribution is a good fit. And then the alternative is the latter where the distribution is not a good fit, right? So we're testing the claim that it is a good fit. So we're looking for is a good fit. We're looking to keep the null hypothesis, right? We're looking at, no, this is, they're claiming this, they're advertising it, they're going, Acme's marketing with these percentages. We're going to go with it. So we want this to be a good fit. So this is a case where our null hypothesis is our claim. All right, so to test this claim, we're going to go to statistics in our calculator and then go ahead and go to edit. And you're going to put your observed values in list 1 and your expected values in list 2. So if you haven't done that yet, go ahead and pause the video and enter those. So once you've done entering these, go ahead and go to stat and then go to test and go all the way down till you see a chi-squared Goff test, but it's goodness of fit test. So go ahead and select D. And when you select D, it defaults to list 1 being observed, which we did, and then expected is list 2. Our degrees of freedom with the goodness of fit test is the number of categories minus 1. Notice I have 1, 2, 3 categories of baseball cards. So if I have 3 categories of baseball cards, that means that I would have 2 degrees of freedom. Okay, go ahead and hit calculate. So we can see here, here's the chi-square that it wants us to round to 3 decimal places. So we're going to have 6.389. Our degrees of freedom, we already said, was the number of categories minus 1, which is 2. And the p-value rounded to 4 decimal places is 0.04 410. We always have to be careful when 9 is the last digit and our test digit is above 5, then this 9 moves over 1 ahead, which is 10, right? So 0.0410. Is the p-value less than the alpha? Where our alpha was 0.05 and our p-value is 0.0410, so the answer is yes, our p-value is smaller than 0.05. So if our p-value is smaller than 0.05, that means we have to reject the null. And don't forget, the null hypothesis is that the distribution is a good fit. So this means that our claim is being rejected. If our null hypothesis was our claim and our null hypothesis was rejected, this means there is not enough evidence to support the claim that that Acme distribution of baseball cards is a good fit. And go ahead and you'll see that each of these are correct.